Functions. I'm definitely going to want a calculator for this. You can hear my calculator going. And I'm definitely going to break this up in a few parts. So I'll do the first page with the first couple examples and then break it off from there. So it's not so much. Okay, square root function. So let's just make like a table for this right now. So we can kind of make sense of this. All right, so this does have to have some number knowledge or math knowledge in terms of like knowing your square roots and your cube roots. I can't remember if I gave you a cheat sheet. If I did, definitely that'd be awesome in this situation. But if not, there's always a calculator. Okay, so let's just graph it and then we'll talk about all this is information. So typically when you graph an equation, you do negative, you do like 0, or -2, -1, 0, 1, 2. But with this, you can't have negatives numbers because it won't work in your calculator. You can try it, do the square root of -1, it won't work. The real answer is I, and that's a non-real answer. So you really only need 0. We're going to do 1, and then I'm going to do 4. And the reason I'm doing 4 is because that's a perfect square, and I know the answer will come out easy. So if you plug in the square root of 0, you get 0, square root of 1, and you get 1, and the square root of 4 is 2. If we wanted to continue the table, like you can plug in 9, and the square root of 9 is 3. Okay, so just some examples of what you can do. 0, plug in 1, you get 1, 4, you get 2, 9, you get 3, and this is not going to look pretty, but it kind of looks like a sideways parabola, but only half of it. Okay, so it could look better, but I'm not very good at graphing on this. The endpoint is this right here. Okay, right here's the endpoint. So if it's just a regular, it says parent function, so it's the basic form. If it's a parent function, the endpoint will be 0, 0. The domain from this is all these values, it's from 0, and everything to the right of it. This graph will not go left. So it's saying you can either write it as x is greater than or equal to 0, or it's going to be from bracket, because you can get 0 to infinity. And this is the way I kind of expect. The range, you can't go any lower than 0. So you'd say y is greater than or equal to 0, or the easier way is saying from 0 to infinity, because this graph will keep going up, it just won't go up very fast. Okay, cube root functions are pretty similar, except for you can get negative answers. So x value, the y value is obviously this, and I'm going to do -8, -1, 0, 1, and 8. Okay, and that's because those are perfect cubes. So let's start with the positive ones. If you do the cube root of 0, you just get 0. If you get the cube root of 1, you get 1. And the cube root of 8, since it's a perfect cube, is 2. So we have 0, at 1 it's 1, and at 8 it's 2. So this actually grows a lot slower, and that's because of the bigger the root, the slower it's going to grow. And then if you did -1, when we did cube roots with the negative, I said the negative gets kicked out. So this is just -1, and the cube root of -8 is -2. And so this is going to look really ugly, but it looks something like this. Okay, so this doesn't have an endpoint because there's no end to it, right? But it has a turning point, and that is right at the origin. And mine doesn't graph very well, so it's really hard to see how it turns. The turning point is 0, 0. The domain for this, because it's going to keep going left and right, is going to be from -infinity to infinity, or all real numbers. And the range, this thing's going to keep going down very slowly, though, and it's going to keep going up very slowly, but it will have a range of -infinity to infinity. Okay, we're going to talk about transformations too, and this is stuff we've already talked about, and this kind of got cut off, so I'm going to rewrite it. Not that it's going to look any better, but it's not cut off. Okay, the k is not in that radical. The n right here is just saying that it doesn't matter what type of radical it is. It can be a square root, a cube root, a fourth root, a fifth root. This rules all apply, okay? So h on the inside, anything inside a function is going to move it horizontally. And we've talked that it's always the opposite. So if it's adding, it's actually moving to the left. And if it's subtracting, it's actually moving to the right. Okay? K is what's going to make it vertically shift, so up and down. This is normal, so positive is up and negative is down. Okay? The ending or turning point is always going to be basically it's kind of like the vertex. It's kind of what you can think of it as. Okay? And that's just going to be the points H and K. Okay, if this is negative, the graph is going to be reflected, so it's going to be reflected over the y-axis particularly. Okay, And if a is greater than 1, it's going to vertically stretch it. And if it's less than 1, so just write less than 1, it's going to vertically shrink it or compress it. Wow, I totally butchered that. And these are things we've talked about this school year, so it's not anything new. It's just we haven't done it in a while, and I imagine we forget how to do it. All right. So this got cut off, so we need to go to the other side. Right here, you're going to basically say what the transformations are. So we're going to go through and figure out what those are. Okay. So in this first one, we have two transformations. Okay, this is a square root function, so it really should look like this. And there's two different things tacked onto it. That's how I know that there's two transformations. Anything under the radical is going to move it left and right. So since it's -7, it's the opposite. So this is actually going to move it right. And I'm going to put U for units, 7 units. Anything behind the radical, not in it, is going to move it up or down. So this one's going to move it up 2 units. Okay, so this should be something that you kind of remember, I would hope, since we kind of did this already. Let's get down to 4 because this is a square root function. And I'm going to ask you how many different numbers were tacked onto this, or things that are different from the square root of x. Well, that's one thing that's different. The 1/2 is. The -2 is something that's different. And the -6 is something different. Those are 3 transformations. That is an easy way to compare and figure out how many you should have. Now, let's start with the inside. I always like to do left and right first. So since it's the inside of the radical, it's underneath of it, that's going to move it left or right. And since it's negative, it's going to do the opposite of what you think. So it's like 1, and it's going to move it right 2 units. Anything at the end is going to move it up or down. Since this is negative, it's going to go down. And then anything in front is going to shrink it, compress it. So if the number is bigger than 1, kind of like 2, that would stretch it. But this is less than 1, so it's going to compress it or shrink it. So vertically shrunk, and always by what, and you're going to put by 1/2. Okay, I need to know what is going on and how much. So you need to tell me what is going on and how much of it is happening. Okay, so number 2 and 3 are different because these are cube root functions. Okay, so if you look at number 2, cube root functions, this is the parent function, so that's what we're comparing it to. How many different numbers are tacked on or different? Well, there's one with the 4 and the 1. Okay, since there's no x minus a number or x plus a number, it's not moving left or right, so we don't have to worry about that. The negative one's outside of it, it's not in the radical, so that means it's moving it up or down. So if anything's added or subtracted at the end, it's up or down. So this is going to go down 1 unit, and we hinted at, I should have put units, but whatever. We talked about it in number 4 just a few seconds ago. Anything in front is going to stretch it or compress it. Because this is bigger than 1, it's going to vertically stretch it, which means it's going to grow a lot faster. Stretched by 4. Okay. Now on number 3, this is also a cube root, just like number 2. I kind of paired it up that way. And we have to say how many operations or numbers were added on to the original. So there's a negative, so that's one thing that's different, and the 3 is the other thing that's different right here. So there's 2 transformations. So I always like to do what's in the inside first. It's just what I like to do. You don't have to. Since it's adding on the inside, it's the opposite. So it's not going to go to the right like you think. It's going to go to the left, and that's this weird displacement thing that happens. The negative is the other thing, and any negative always makes it reflect. And you don't need to put over the y-axis. We're not going to talk about that. Okay, so number 5 we're going to do, and then I'm going to stop the video and do graphing as a separate video, okay? So the first thing you notice on here is it says the square root parent function. Okay, so let's just start there. What is that? Well, the square root parent function is f of x equals the square root of x, okay? So let's start there. We're just going to take this chunk by chunk. It's reflected over, change this to y-axis. Okay, change that to y. We're not going to do that. That's just too much work. It's reflected over or across the y-axis. So what does that do? Well, that makes you have a negative out in front. So I'm just going to put a negative symbol to keep that in mind. So actually, I'm just going to write it here. Negative and then square root. And we don't know what it's going to look like, so I'm just going to leave room to write. Okay, so that's taken care of. And then it's shifted 7 units left. Well, if it's 7 units left, that has to go inside. Anything that's left or right has to go underneath the radical. So we'd have x, and even though left is usually negative, we have to do the opposite with x when you're dealing with left and right. So it's positive 7. So that's taken care of. So this is the plus 7. And the last thing you have is 1 unit down. So that always goes at the end. I mean, it can go out in front, but we're not going to make it that difficult. And that's the y value, so it's -1. So if I really want to clean it up, it looks like this. Okay, that's the end of the first video in the left-hand corner. You'll see the link to the next one. Hope that helps. See you in the next video.